sounds so painful. So next up we have Raquel Radoman, who holds a BSc in Electronic Engineering from the Military Institute of Engineering in Brazil, an MSc in Automotive Electronic Engineering from the University of Brighton. He's also doing a PhD at Loughborough. On top of that, he's a captain in the Brazilian army. Talking about open architecture.
Hello, everyone. Good afternoon. So, like we said, I'm a PhD student at Loughborough University. I'm investigating the implementation of open architectures in military systems. And today I'm here to present our paper on open architecture. Is it a realistic approach or is it a pipe dream? So just introducing the other authors as well. Michael Henshaw, he's my supervisor. Tim Rabatz and Mike Wilkinson. Tim Rabatz here. So they are also visiting professors at Loughborough University and co-chairs of the Architecture Working Group. And before we start, just would like to say it's a great honor to be here. Last year I was attending the conference, I was in the audience, watching all of these amazing presentations and hoping that one day I'll be able to present something, and then here I am. I hope you will learn something from it today. So just before we start, is everyone here familiar with the concept of open architectures? I believe most of you might be, but just to give a very, very brief definition, will be any architecture that is made available to any organization out of the original enterprise. I'm going to go deep into more definitions later, but just to create a baseline here. And then I'm going to briefly talk about why I'm working with open architectures, why is it interesting for me. So I'm a captain of the Brazilian Army. I work with military vehicles since I graduated back in 2013, and more specifically, I do the supervising or the integration of the systems, and it's done by the prime. So they're really good with the mechanical installations, with the stability, with the electrical distribution and energy distribution, but the data part, it's still missing. We never requested it from them. And I never thought it was a problem until I came across the generic vehicle architecture, which is an approach by the MOD. And it's an open architecture. It's basically defining what are the main capabilities that are necessary for vehicles, the data models. So we based on that, and I brought it back to the Army. And then I tried by initially proving that we can have some operational benefits. So the example here in the image is we tried to put everything in a single display. So the information from the driver, from the gunner, the feeds from the cameras. And then we created it in a proof of concept, so we showed them that we can actually come up with some benefits when we use this approach. But what I didn't realize back then was that it would be so difficult to actually implement it, not technically, but from the organization point of view. Because, of course, that will require some changes in the mind thing from the decision makers. Any change is difficult, especially in the public domain. Because whenever you have to change, it means that you need to invest in something. And whenever we need to invest in something, we need to prove on why we invested in that. So that's one of the main difficulties. And here I am trying to investigate a little bit more on these difficulties and how to address them. So this is just a presentation outline. It's like an academic paper, introduction, approach, analysis of the findings, future work, and then conclusion. Now let's start with the introduction. The main aim of our paper was to present a review on the usage of the open architecture, focusing on the defense domain, but also leveraging some of the issues from the commercial domains, and seeking to provide guidance on future endeavors. So we do that by discussing some different definitions. Definitions is always important. Principles and motivations for open architecture, discussing the preliminary findings and in terms of barriers and enablers of the implementation of this approach. So just to give you a bit of context, open architecture is something that is not new. It's been there since the 80s. The most classical example is the IBM computer. Ever since then, they realized that it wouldn't be able for them to attack both the hardware and software parts. So they started to modularize it, to make it more configurable. And it was a very good approach ever since then. In the air domain, we have the need to have different pieces of equipment from different suppliers. And what we are noticing is there is always a resurge of interest in this theme of open architectures, following even for every of the technological shifts. So now we have the digital transformation, for instance. Data as an asset, data exploitation, so we need to have access to this data. In the previous work, we mapped the so-called open architecture standards applied over time, and then we came up with 80 results. If you're curious, You can have a look in this QR code or just Google it later, mapping of open architectures. And, well, mostly it was from the defense as well, like our focus, land, air, maritime, multi-domain. In the commercial field, we identified applications in the avionics, airport security, digital health, insurance, satellite, IT. And we were classifying both in terms of domain and applications, but we were also aiming to see the different types of governance and motivations. And one of our main conclusions back then was how it evolved over time. So initially, in the defense specifically, they were very worried about the obsolescence and limited updates of the equipment. So they were starting to analyze how to replace this equipment with components, commercial off-the-shelf components. And as the time evolved, now we've seen a rapid technological advance and the need to insert new capabilities. We also have different types of war scenarios, and this is also implementing and serving as a motivation. And that made the focus of open architecture to shift from purely technical to include a more enterprise approach. And these are the different types of governance that we observed. So most of the standards are owned by the government. Some are by a group of nations, like NATO, or when some nations come together to agree on the standards. Some are from companies, consortium, or open groups, international groups. And in terms of access conditions, so how open is open, some of them are freely available, some are available but you have to pay for it, some are determined by the government body, so the generic vehicle architecture, for example, is owned by the UK, but it's not just available for the UK. But we also have some that are restricted to a group of interest. And here's just sum up to show some of the main architectures at the moment that are identified within the land, air, and maritime domain. So just to sum up this initial context, we saw that there's this resurgence of interest in the open architecture over time. We saw that there's a variance in terms of ownership type, accessibility, and community of interest. And we also saw that there's a motivation changing over time as well for the application of open architectures. Now moving to the methodology. So how did we proceed this review? So we combined both the explicit knowledge with tacit knowledge. So explicit knowledge is the literature review. It's how we always start. Let's not reinvent the wheel. And we noticed that there's a lot of documentation from the US here, not so much from the other countries. So that's why also the tacit knowledge was important. So we spoke to many people, we interviewed some people, some experts on the field. But the problem with this tacit knowledge is we were more restricted to the UK. And we managed to talk to some other people from other countries as well, but mostly from the UK. But it kind of balanced the dominance of the US at least. In terms of usage, we considered the usage of open architecture during the whole time, focus on the more recent ones, but of course, understanding how it worked before, it's important, largely within the UK domain, defense domain, like I said, but also using some examples from the commercial domain. And the literature review, of course, we only analyze things that are available in the public domain, mainly the gray literature, so government documents, so the UK, MOD, US, the European Defense Agency, industry white papers, articles, defense magazines, and even the standards in itself. Sometimes they mention the motivations for that. Academic databases, most was from the gray literature, but you can also find some things here, especially from research centers or institutional blogs. And from the tacit knowledge, like I mentioned, we discussed with individuals that are involved with open architectures from multiple perspectives, both from the supplier and from the government, and from the different domains. And of course, we also consider our own personal experience. So now starting the analysis of the findings, the definitions and principles of open architectures. So first of all, we couldn't identify any formally agreed definition for what an open architecture is. And most of them were just elaborated within some specific work groups, just to come up with a common understanding. So I'm bringing here some examples, starting from the literature. So one from the Defense Acquisition Glossary, DAW. And a technical architecture, open standards supporting a modular, loosely coupled, highly cohesive. It also mentioned publishing of key interfaces and with full design disclosures. So here you can have the focus on some of the characteristics that they think are important. They're associated with the openness. Key interfaces again. And they also aim in having a full design disclosure. And their community of interest here is, of course, the US. Another one from the UK, which was one of the work that my supervisor worked with, in the assessment of open architectures within the defense procurement. And they say that's applied to a system in which the architecture is published in sufficient detail to enable change and evolutions and from any supplier. So here we have a little bit more of motivations, and it states that it's also in sufficient details, not necessarily the full design. And it opens up a little bit the community of interest from any supplier. Also from the interviews, so in this case, again, highly modular and uses freely available standards and architectural patterns. So for this person, the fact that it's free, it's very important, open. And independently, ideally from an independent body, not necessarily from one that represents the government or from the companies. And this other one brings more motivations as well. And it says that it has to be a technological and economical motivation. So it's already bringing these two layers. And it sets a methodology to solve data integration problems, data communication problems. And the motivations will be to reduce the spiral upgrades problems, to bring operational advantages, to reduce through life cost. And you will do that by standardizing the interfaces. And it was also important because it highlighted the fact that it needs to leave space for proprietary interfaces. So open architecture is not a one-size-fits-all problem. And especially when the technologies are not supported yet, or when the technologies are very critical. And we also created our definition ourselves, and I normally use it when I try to explain to people that are not very familiar in the field. So open architecture will be a technical approach based on the definition and documentation of the key interfaces. So here we're talking about electrical, electronic, mechanical, computing, and preferentially based on widely used and available standards. In sufficient detail, so what do I mean by sufficient detail? So that the third parties can understand and can modify it in the future. For a group of interests, so you need to define your group of interests. It could be, like before, we were discussing in the governance, the group of nations, just within a nation, consortium. And here the main issues are the openness. So where is it open? How much openness? And for whom it will be open to? Then, of course, just continuing, this technical approach is also part of an open environment that is composed by a commercial approach. So here you have the needs of the government and the industry to work together. And it aims to facilitate the cost-effective modification of components and capabilities along the life cycle. So the main motivation is cost and effective and modification. There are also some similar terms when you search for open architecture. So the first one is open system. You can think from the physical definition. So open system is one that shares mass, energy, and information of its environment. Or it's an open system because the interfaces are open, which is more a context. Sometimes they say open systems architecture, because if you simply say open architecture, people may think that's the traditional architecture of civil engineering, which can also be applied. Open architecture approach, and normally when people use approaches, because they are trying to emphasize the need of technical and the enterprise together. And some of the terms are normally used. Open interface and open standards, of course, is very important for open architectures. Open data and open source, that depends on how far do you want to go with your openness. But more importantly, the open data available within the main interfaces, and the open source only if that's really important for you. But you have to be careful because that may hinder the innovation or the participation from the companies. Now talking about principles. Well, it was difficult already to find the definition of open architecture, so it was also difficult to find principles. We don't find principles of open architecture, but we find it within the context of particular programs and projects. So a good example is the modular open system approach of the US, and then they're trying to connect the vision with the principles and the benefits. So their main vision is to bring an acquisition strategy to achieve affordable, evolutionary, and joint capability. And the principles associated are, first of all, establishing an enabling environment, again, participation of industry in government working together, and some of the characteristics we mentioned before, employ modular design, design the key interfaces, select open standards, and also certify conformance. Because it's easy to say it has to be open, but what does it mean by it has to be open? So there has to be a way to find the conformance, at least within your own program. And they are associating, again, with the main benefits. These are change, reduced total ownership cost, cycle time, enable joint integrated operations, and risk mitigation. And this is just another example from the literature, and it's not exactly a principle, but it's one of the levels associated with the openness. So they associate the flexibility, extensibility, or the need to be customized, and then they go down into other levels. But again, there's no formal definition of what are the principles. So before we go to the assessment of open architectures, we can conclude that all open architectures are open, but some architectures are more open than others, trying to paraphrase here the Animal Farm. And so we could see that we have some very similar definitions, but different approaches on these levels of openness. And it's important to complement these definitions with the principles associated to the intended benefits, just like the MOSA approach did, and to have these assessment methods to follow these principles, to see if these principles are followed along the life cycle. So in terms of assessment of open architecture itself, again, it's a field that is not very well defined. We have some quite old tools, but some of them are still being used. This is one example from the US Navy, and then they classify in 9 different levels. The very first one is the closed system that is designed, very design specific, all the way down to the last one, which is one that fully supports changes. And the way they try to analyze these levels is by seeing in terms of levels of documentation, widespread use of the standards, easy of making a change, also IP considerations, and then consider both the aspect from the perspective of the open architecture and from an open business model. Other tools are normally assessment questionnaires. So basically, to what extent do you achieve this level? And then you answer some of the questions. But again, this is just another way to try to quantify when something that is normally more quantifiable. So I still think that it's too difficult to assess these open architectures. Another example from the literature, trying to divide in terms of culture. So they think about the organizations and the employees, if they are being trained to use the openness, architecture, interfaces, design, data, and down to the implementation. And we also think that it would be interesting to find a way to see the openness from each of the stages of the architecture. So for example, from the capability level, you have the capability compositions, and the open specifications could come in the inter-capability service agreements. From the operational side, you have different operational threads. You can divide in modular. Then again, these interfaces and information exchanges could be seen as a way to think about openness. And then similarly for the logical level, functional interfaces, and down to the physical integration, some of the spatial mechanical aspects as well. So just summing up this part, the assessment tools, they're very important to indicate of the current levels of adoption of the approach as is, and addressing the openness in each of these levels of the architecture could potentially contribute to the completeness of this approach. And the results in both the technical and programmatic areas, they could be combined, and they have to be combined if you are thinking of using it for the progress of reading these stages of openness. Now moving to the different motivations. Well, I mentioned some of the motivations already, but as you can see, they can be divided into commercial, technical, and operational. Yeah, so starting with the commercial. The first one, to prevent vendor lock-in, so to have the freedom to decide on multiple suppliers instead of being dependent on a single one. As a consequence, you'll be able to enable competition, and when you enable the competition, you can expect some life cycle cost reduction because you have more rooms for negotiation. But these benefits are very client-focused. And now with the shift to a more collaborative market space, so thinking about how to access different data, how to combine this data to create further capabilities, we are seeing new opportunities for collaboration and also flexibility to adapt to multiple customers. From the operational perspective, first of all, capability insertion, because sometimes your prime won't be able to provide that capability, and then when you open it up with an open architecture, you facilitate, for example, small, medium enterprises. Flexibility and adaptability as well. Faster time to field, because it's easier to integrate. Easier, not easy. Innovation and interoperability. From the technical perspectives, the technological modification and upgrade becomes, again, easier. And you avoid rework and reduce some of the integration risks. You come up with swap C reduction, so swap is size, weight, and power. So the very first example I did with my personal perspective, when I try to reduce the number of pieces of equipment, when we do that by enabling to reuse the data from the other subsystems, you're actually contributing to this reduction. Increase commonality, and you enable as well the data collection. The data will be available for you, so you can further use it for artificial intelligence or machine learning applications. You also notice some motivations when comparing multinationals with nationals approaches. So normally the multinationals think about interoperability and interchangeability. The national are more focused on the swap C reduction and the capability insertion as well. Consortia normally think about collaborate to support in platform capabilities. And government owns are thinking about avoiding the vendor lock-in. When you think about family of systems, of course, the reusability to avoid rework will be a good consequence to facilitate the logistics, to benefit from economy of scale. The command and control on unmanned systems think about interoperability and data availability. And soldier systems, again, the swap C reduction works for them as well. So you end having a reduction in physical and cognitive burden. And when comparing commercial with the defense domains, the main issue is the market size. Of course, the market size, both in terms of clients and supply, is much bigger within the commercial domain. There's more competition and more variety, which can make it more difficult, actually, to come up with an agreement on the standards. But it's normally when we have more examples of open architectures being applied. And the defense normally, the commercial normally thinks about reducing integration efforts during the development, whereas in the defense we think about reducing this also, but the capabilities along the life cycle. So summing up these parts of the motivations. There are many common motivations for open architecture, but the priority varies according to the scenario and according to the community of interest. And it's important to understand these benefits and these motivations and priorities before selecting the strategy of implementation. Now going to barriers and enablers. So the barriers we identified from the enterprise and technical levels. Starting from the enterprise levels, the clarity of the purpose, what is the aim actually? Is it the openness per se? Or what is the main benefits that you are trying to achieve? Constant substitutions of personnel, especially from the government side. So for example, if you don't have a commitment yet, if you don't have a policy yet, and then you have a leader that is really willing to apply the open architectures, but then in 2-3 years he's not there anymore, then you have to reconstruct this buy-in and this idea of having the open architectures, and that's something difficult. You initially have some supplier resistance, initially, especially if you don't show that there's a benefit for both sides. And it's, of course, a long-term commitment, a long time to have a return of investment. So there is an investment that initially necessary, and that comes as a challenge for many governments, and difficulties in setting up the governance. From the technical perspective, the process to agree on a standard and the time to mature it's very lengthy. So all the examples we have, the AutoSAL, which is a very successful case. It's been there for 20 years. It's been evolving with time, but it's quite of a lengthy process. And emerging technologies are difficult to standardize or to fit in current architectures. Openness versus other attributes, so safety, security, performance, and the risk of the architecture being too specific or too generic. When it's too specific, it may hinder the innovation. When it's too generic, it won't be fit for purpose. And as an example of the enablers, I'm bringing again the modular open systems approach, because this image is very good. It shows the whole ecosystem that is necessary to achieve the main benefits intended by the open architecture. So you have to consider the openness both in the program management, in the systems engineering, the contracting need to adapt as well, the industry, how the industry is going to participate in this process, the governance, training and education to avoid that problem of the changing in the personnel I mentioned before, policies and guidance. And as some recommendations, so it's important to work, if you are starting, on an architecture standard that's very well documented, resourced, and maintained with an active community. Otherwise, with time, that wouldn't be used anymore, so it would become closed. Understand the motivations for the implementations, the problem set, and the principles that you want to be guided on. Of course, it's an architecture in first place. It's an open, but it's also an architecture. Clearly states the commitment towards the approach, mentioning the benefits for both parts, and including compliance guidances. And promote training and tools that are understandable by non-experts as well. So just summing up, align the expectations by prioritizing the main motivations and stating the benefits for both parts. Express the commitment by creating policies and investing in the ecosystem, while also acknowledging the challenges. So as future work, most important part for me will be because here I'm presenting the barriers and the enablers, so it's interesting to put them all together to see how they relate to each other. I think that's one of the main outcomes of our follow-on activity, and with that, we believe we can provide some guidance on future applications of open architecture. So for example, I can get these main drawings of how the benefits are related to the challenges and go back to my army, shape this with their particular environment, trying to understand further down why it's difficult for them. And then from there, you can actually come with the guidances on how to proceed and how to implement it. So just to conclude, recapitulating the aims, we spoke about how we did the review, we discussed different definitions, different motivations, some of the barriers and enablers. And so finally, is open architecture a realistic aspiration or a pipe dream? Well, we've seen from the cases of success, the GVA, AutoSAL, FACE, many of the examples, and increased usage over the years, that it can be a realistic aspiration. But of course, it's not an easy journey. It's not a silver bullet. Like we said, for new technologies, it's difficult to adapt to openness. You need to mature first. It's not one size fits all. You need to shape it to the reality of your government. And it requires understanding, alignment of expectations, transformations, and long-term commitment. So, of course, aim to embrace new opportunities, but don't forget the enablers. Open architecture can be an enabler for these new digital transformation, for example, as we have at this moment. So thank you very much. If you have interest, please get in touch, and time for questions.
title myself.
Duncan Kemp, Ministry of Defence and also Loughborough University. Great presentation, Raquel. You started to touch on something I think is really, really important, which is kind of something around the market dynamic of some situations it makes sense to collaborate and work in this way, and other situations it doesn't. And I wonder if you've kind of seen anything that says in the first one it's fertile ground and this takes off, but in the latter it kind of, despite having all the enablers, it doesn't quite. Is that something you've seen or thought about or are going to be looking at?
I think this is something that I'll be able to understand better once I bring back this work to my reality. Why is it so difficult to implement in certain situations? So probably we need some readiness. So I think that understanding the principles of the systems engineering, having the systemic thinking of understanding the importance of the data, I think this is one of the preliminary issues. And then creating the community of interest. If you can't create your community of interest, there's high chances that it won't be ahead. Even if you simply decide to follow an approach. So for example, if you say, okay, let's go to the UK government and try to see if we can collaborate with the GVA. But implementing it is also another issue. So we need to create our community as well back in Brazil to say, oh, you as an industry, it will be interesting for you to also follow what we are saying, because you can also benefit from that. So I think if you don't manage to create this community of interest, that will be a bad sign.
Hi, thanks for your talk. It was very, very interesting indeed, and I love the thorough approach there. Matt Wyndham from UCL, kind of maybe riffing on the previous question. I think it's about the economics and about the depth, whereas in, say, consumer microelectronics, there's lots of open or kind of open-ish standards, and the sponsors of them have maybe invested very, very heavily to create, say, the programming languages, the APIs, the marketplaces that we use every day in order to provide the benefits that come from this very long tail. And I think you're saying that in the defence situation, there is this tail, and it could be very long, but it's also maybe decades long or very thin. So that gives, I think, defence acquisition a bit of a gamble, right? Do they invest in openizing a particular binary contract, or do they package it in a way that it might be useful later on to plug into an architecture? So do you think defence acquisitions should be aiming for quick wins or prioritizing strategic things? How do you think they should approach it strategically?
Yeah, I think that's a great example of a challenge, and especially because this is something that in long term, if you simply think about it as a political goal, so I think the main leaders are there for just 3 years, so they want to see the results while they are there in charge of the situation, so you won't be able to see it in 3 years. Open architectures, they are a bit long. But definitely the time to perform the acquisition is also a problem, and it's not related to open architecture, but it's an approach as a whole. And we are also very, very thorough, very worried about how we perform it. Like I said, whenever we invest in something that is public, you need to justify it afterwards. So there's a lot of careful steps that we take, but as a consequence, of course, you see that it's a very lengthy problem. So I agree with you, definitely a more agile way to perform that could be a good guideline, yeah.
Thanks for the presentation. Really, really interesting. So Andrew Bush from Babcock International. One of the slides you put up earlier was on Musa and the advantages and the approach. Just wondered if your work looked at the disadvantages and the risks associated with that and how you would look to mitigate them.
Yes, I believe that the challenges that we see will be to adapt to these new technologies. So as new technologies come, we will probably need to readapt the architecture in itself, and that will take some time to adapt. And yeah, I think this is one of the most classical examples that I can give at the moment. or other cases on how to relate to other non-functional aspects, so the safety and the security, how do you divide it within your own architecture is also a challenge, definitely. Anything else?
I can't think, I mean,
Yeah.
what I think Raquel has done is very usefully summarise 20 years of work that has been ongoing in the UK that we haven't spent the time to really understand. So we noticed some differences between the different domains, even within defence. And going back, I think, to Duncan's earlier question about cost effectiveness, there's some recent information on one programme in the defence domain where that particular project believes it saved 30% as a result of introducing open architecture. And I'm sure as the research progresses, we'll understand more on topics like variation of the supply base and how appropriate open architecture is and different forms of open architecture, depending whether you have dominant suppliers or a more equal competition basis.
Yeah, thank you. I actually have a question for myself, which is I've worked in a few programs where they've tried to do this thing of bringing in open architectures, and in fact, there's always been this question of your stance. Are you going to be a design authority, and if you mandate things in shoes and say you must do this, and therefore carry the risk of what you've actually designed and chosen, the fact that you could be wrong, it could be costly, you could make all these bad mistakes, or do you want to be like an architecture control board and sit there and have stuff brought to you to be assessed, and you can say, oh, I don't have that. That's okay, that's not so good. And basically, that whole stance thing, did that come up at all in your research, that kind of different ways of playing the game?
Yeah, so the first case would be the US, for example, because they have a very big industrial base, and they also have a lot of knowledge in the house. So I think they can afford to try to risk and mandating it, but of course they're constantly talking to their own industrial base. But if you don't have much of this knowledge in the house yet, I think perhaps one of the best approaches, and it's what I've been seeing in these different governments, is to try to collaborate and then wait for proper architecture to be defined within your community of interest. Yeah.
Yeah, I've certainly had things to say that if you hold this path, then you have to do all this stuff. And they get a bit shocked and go, yeah, maybe not.
And it's going to be quite a challenge for countries like Brazil, which doesn't necessarily have the industrial base that we have. So those are some of the issues that Raquel is contemplating.
And that's why it's a long-term commitment, because it's not a fast definition, yeah.
So any more hands? I've got one over there. So last two questions.
Thanks very much. Really good presentation again. Peter Douglas from Synoptics. For defence, where the client or the government has a clear benefit from open architectures, but suppliers don't, how do you incentivise them? Any thoughts around getting a supplier to adopt an open architecture where it's directly in competition with their commercial constraints?
So I think it's a lot about showing that this can be a win-win when you think about the whole perspective or the number of capabilities as a whole, not just provided by single systems. This idea comes and shows up. So, for example, I recently participated in a conference on survivability, and they highlighted how there was this shift initially from just equipment or like the EPS, the protection system that was just the group of equipment, or how it could work in a more collaborative environment. And if you want to work in a collaborative environment, you need to open up for the possibilities of having other companies to come up with these different pieces of capability to combine with you. And this is something that the client is requesting for as well. Oh, we want a systemic view, and there's no single company that will be able to do it by itself. Or if it does, it goes back to the problem of the vendor lock, which they are avoiding. So yeah, so I think it's by providing, not focusing perhaps on the openness and the benefits, like I was showing, just for the client. It's also showing for them. You will also have more capabilities. It will be easier for you to integrate your problem, so you are also winning. And it's even easier for you to show your capability when you know how to integrate other equipment as well.
Final question.
Hi, Tim Breakspear, WAE. So you mentioned AutoSAR was one of the most successful ones around. Working with it at the moment, it appears to be somewhere most of the defence open architectures would love to be. It's got tool chains, the tool vendors, multiple different tool vendors providing tools, an engineering base of skills that are fully trained in it and deploying it. Is one of the aspects you're going to look at is how AutoSAR became so successful and the longevity of it, because it appears that's the gold standard of where things should be, and it'd be really interesting to see how it got there.
Yeah, so from the AutoSAR perspective, they've been trying to increase this community of interest every time more. And like I said, it was not just for the process, for the architecture itself, but also for the tools. So more vendors are adapting to this approach. Within defense, it's a little bit more difficult because we have very specific clients. Normally, this architecture is applied just for this country or for the other country, but we have some architectures that are opening up. So I think what the UK MOD is doing, the GVA, for example, is interesting because they're trying to bring companies from other countries or even maybe making other countries to add or adapt to it. And the GVA, I think, has been there for 10 years. The AutoSAR has been there for 20, so maybe that's one of the futures for the GVA in the future. Yeah. It's funny because I'm talking about the GVA. GVA is in a UK approach, but yeah, that's what I've been noticing.